Section 2.4 in the text ends with the strict definition of the limit equaling infinity. Now, this is definitely something that I want to just expose you to, and I'm not going to test you on it. It's really easy to get bogged down in section 2.4. I don't want to get bogged down in section 2.4. I want to just expose you to it. Some of you who are going to be math majors will probably be a little more interested, and we can work on the side. But for the most part, we want to just see what these epsilons and deltas are doing for measuring closeness. The thing is, here, to say that the function is getting close to infinity, what the heck do you mean gets close to infinity? I mean, infinity is really pretty standoffish. You can't get very close to it. And so here I still have this if x is close to a thing, right? The difference between x and a is less than some delta, so x is close to a. Then, what do you mean f of x is close to infinity? Well, what they're saying is that f of x is just bigger than some n. So rather than using epsilon as a measure of how close you are to L, m is a positive number, which is saying f of x is bigger than m. So if m is your measure of bigness, right, we're saying the function is headed to infinity. It's getting really big. So if m is your measure of bigness, we're saying, hey, we can get bigger than that, right? And I switched to the next page here. Yeah, so the picture is, looking like this. You tell me how, I'm claiming the function's getting arbitrarily big. It's headed to infinity. You tell me how big you think big is, and then I say, look, for delta being, from a minus delta to a plus delta, these x's are going to give me y values that are bigger than what you said big was. Right? And if no matter how big you want me to get, I can say squeeze this delta in small enough so that all the x values get me that big, then okay, I'll say the limit is infinity. Right? Again, to say the limit of it is infinity is a specific way of saying the limit doesn't exist. But still, we can use these deltas and m's to get that idea quantified a little better. Okay. Likewise, they have one for what do you mean it's headed to minus infinity? Well, then they're using n to be a negative number, and they're saying, well, how far negative do you think it needs to be? And if you can always get the function f to be more negative than that, right, so that f can be made to be less than n, then for x is close to a, the function is really very far negative, then we'll say, okay, the limit is negative infinity. Okay. Again, this is a matter of exposure to you, not something that I think you need to master at this time, but exposure to it for your first time through here, I think, is a good thing. Okay, so there you go.